Okay, so folks, let's get started. Good morning, everyone. Good evening for folks who might not be in the West Coast Pacific time zone. Welcome and thank you for joining us for the Platform Line's 9th AMA session. Typical format of these sessions, these are Ask Me Anything sessions. These are useful for our community of freemium tier users, but also in general, any Platform Line customers that might have questions on specific topics. We try to answer the questions to the best we can. And then for the ones that we can't, we take follow-ups and we will get back to you on any specific questions you might have that we couldn't address in the session today. Today's session is about multi-cloud Kubernetes. The reason for this topic is twofold. Multi-cloud has been probably one of the most popular use cases for deploying Kubernetes because containers are very platform agnostic. And so Kubernetes and containers are very much suitable for an organization that is trying to reduce its dependency on a specific cloud provider or a specific on-prem platform. It's just one of the many reasons for going multi-cloud. So that's one. And then the second reason why we think this topic is relevant because Platform Line Managed Kubernetes just introduced a bunch of new features that are very relevant in the multi-cloud space. So we will, in this session, talk about multi-cloud, why some of the common use cases that we see of users, customers around going multi-cloud. And then we'll follow it up with a demo where we'll showcase some of the sessions or some of the features of managed Kubernetes, especially the ones that have been introduced in the most recent release, which is 5.3 release. I see a question here, will this session be recorded and sent out? Yes. All of our AMA sessions are recorded and are uploaded to the website under resources, also on the YouTube channel, and I believe it will be sent out to all the attendees as well. Okay, so with that, let's get started. So as we mentioned, to get more out of this session, feel free to join on our public Slack channel on the AMA channel of our Slack. The channel will be used to submit your questions, comments, etc. And like I said, if we can't get to you during the session, we'll definitely follow up after. As a reminder to everyone, you can go to Platform Line website if you haven't already. If you don't have a free tier account today or you're not a Platform Line customer, you can always go to our website and create a Platform Line Managed Kubernetes account. It's completely free to do that. You can do that now as you listen to this session, and you can see some of the features that we'll be talking about or showcasing in the demo live there. Just a note on some of the multi-cloud features that we'll be demoing, those features are going to be live. They're just hot off the press. They're going to be live in about a week or so on our freemium tier. So you may not find everything that we're showing in the demo, but I'll call out explicitly what's in the product today and what will be available in a week from now. Okay, so with that, let's go next. So I'll start with introductions. I am Madhura Miskowski. I'm head of product at Platform Line, co-founder. Prior to Platform Line, spent quite a few years at VMware, primarily as an engineer, contributing to a number of their virtualization management systems and platforms like VMware vCenter, DRS, VMware vCloud, for those of you who may be familiar with VMware Stack. And prior to that, I spent about a year or two at Oracle, where I was working on their relational database automatic storage management side. At Platform Line, I look across our various products, and specifically our Kubernetes enterprise product and our premium tier. David, would you like to introduce yourself?
Sure. Hey, everybody. David Diroff. I am the Developer Relations Manager at Platform 9. I've been writing code for longer than I'm going to admit. And I complement Madhura with the product and take a developer point of view and can answer any questions that you might have about deploying applications, using applications in these environments, that sort of thing.
Great. Thank you, David. Okay, so kickoff. What we will cover in this session, I talked about this a little bit. What are the use cases and benefits of a multi-cloud approach? What are the realities of trying to run Kubernetes across multiple clouds for both developers and operators? And then we'll talk about how do you manage some of these additional complexities, specifically around trying to manage different or multiple distributions, public cloud Kubernetes distributions, as well as just completely open source Kubernetes, or if you're working with specific vendors, Kubernetes offerings, how do you manage those while dealing with the public cloud specific stream of Kubernetes distribution deployments or Kubernetes version deployments, etc. We'll also talk about how do you manage multiple deployments that might be located in different geographical locations, different formats, including on-premise, public cloud, etc. And then finally, we'll conclude with a demo where we'll showcase how Platform 9 tries to help you tackle some of these challenges. Okay, so let's talk about multi-cloud why, right? What is the reason for going multi-cloud with Kubernetes? And just as a note, when we mention multi-cloud in this session, we're talking about both on-prem as well as public cloud, not just public cloud Kubernetes. So public cloud, deploying on multiple public clouds, think of it as a subset of the broad set of infrastructure endpoints on which you could deploy Kubernetes. Typically, in our experience, for the enterprise customers that we work with, we see that large enterprises typically try to go on at least one public cloud and couple that with an on-prem Kubernetes environment. And the biggest reason for that we see is cost, right? We have a number of examples of customers that started off on public cloud on EKS because they've been Amazon customers and EKS is there and it's good enough. It's a good offering from Amazon. And so they get started from there. But then as they grow and the Kubernetes footprint grows, cost does start becoming a big factor. They also start realizing that they have a big on-prem infrastructure footprint that they can leverage to deploy Kubernetes, and their applications won't really be impacted because it's the same underlying platform and API. And so we've seen those customers decide to go on-prem, especially if they have a good management solution across both public cloud and on-prem. Then for cost reasons, they will choose to deploy large Kubernetes clusters that require either specific performance optimized hardware to run some specific workloads, or just in general, potentially workloads that don't necessarily need to run in public cloud. We see them going that hybrid approach. We also see customers going the other direction too, where they start with Kubernetes on-prem because they have large-scale VMware or Linux or OpenStack environments in-house, and that's where the developers, DevOps teams, etc., get started and create their first Kubernetes deployments there. But then the company decides to go hybrid, not necessarily just for cost reasons, but typically for business need reasons. Because as you start moving your applications to Kubernetes, your production applications to Kubernetes, there's a number of factors that come in play, right? Compliance tends to be a big one, which requires you to deploy your production apps for different customers on different environments that might be specifically configured with specific security parameters in mind. And so that might be one reason why you cannot deploy in public cloud at times. But at other times, in order to cater to a customer's geographical needs and to locate your app close enough to where your customers are geographically located, public cloud might be the only option for you if you don't have on-prem data centers available in those specific geographical reasons. So typically, compliance, security, Customers' geographical locations tend to be just some of the business reasons why a multi-cloud Kubernetes solution would become relevant or a requirement for a business. Right. For example, in Europe, when you are deploying your production applications catering to European customers, you really have to keep in mind some of the rules and regulations which may not allow you to share the data plane or parts of your deployment with customers outside of that European region. And so that would require to create a specific dedicated deployment in a specific European cloud provider, etc., so that you have your applications deployed in a more local way to your customers. Some other reasons also include specific partnerships that enterprise might have, which might preclude them from deploying on one public cloud or the other. That's another reason that we see customers choosing one provider versus the other. And then finally, cloud neutrality or choice, right? This is a pretty big one. We see a number of enterprises explicitly making the call to go multi-cloud or on-prem plus public cloud for this reason, even though they may not have any specific business needs or cost-related concerns. As an example, one large real estate vendor customer that we work with, they had this as one of their biggest reasons for wanting to have multi-cloud as part of their strategy. Cloud neutrality is important because once you are able to have your end-to-end stack, not just including your Kubernetes clusters, but all of your tooling that integrates with them, your CI/CD and etc., deployed in a multi-cloud fashion, then you're no longer tied to a specific cloud provider. So tomorrow, if your AWS spend is going extremely high and you're not able to negotiate that down, you have the choice of reducing your number of Kubernetes clusters on AWS and going more or expanding more on your on-prem footprint, or maybe expanding more on GKE or AKS, etc. So it gives you better choice. It gives you better leverage when it comes to negotiating with a cloud vendor if you have that large of a contract. So these are typically the reasons why going multi-cloud can help. David, anything you want to contribute to this before we go next?
You've got it covered. No way.
Great. So let's go next. So some of the multi-cloud challenges, right? So I think it's, to start with some of the obvious points, which is that deploying Kubernetes on multiple platforms, it's not easy to manage unless you have the right product that helps you manage it, right? And this is our honest assessment, folks. This is not because we do provide a product that helps our end users manage clusters across multiple clouds, but in our own experience, a tool that lets you manage your Kubernetes environment probably starts adding a ton of value, especially as you go the multi-cloud route, which is when you have, let's say, 2 to 5 to 10 clusters spread across either on-prem or a public cloud environment. Because otherwise managing or maintaining those clusters is just difficult to do. If you're going the public cloud route, each cloud provider has their own cadence of releasing Kubernetes versions and updating or upgrading your Kubernetes clusters with respect to those versions. Depending on what flavor of Kubernetes offering you're choosing from that vendor, they might be either automating all of the upgrade process for you or parts of it. Like they might be promising or delivering on control plane updates, but the data plane or the Kubernetes node update or upgrade itself might be your responsibility, or it might be a combination of that. And your applications will at times depend on the Kubernetes version that you are running on, as well as you would want some stability in terms of the Kubernetes versions you're running on, because you don't want to expose your applications to the latest versions without testing them first in your staging or your internal test environments. And so, if you are DevOps or Ops, it's critical from your perspective to continue to maintain a specific SLA to your internal developers that are using the Kubernetes, stable Kubernetes clusters for running their CI/CD workloads, or at times even production workloads. So management and maintenance, lifecycle management of the clusters while having production apps running on them becomes one of the critical challenges that you need to address. The second one is if you're looking to automate, especially cluster deployment and etc. And if you're working in one of the environments where your CI/CD requires creation of clusters and destroying them, that's not typically the CI/CD configuration that customers use or we recommend. We recommend creating a pool of shared clusters to do your CI/CD. But if you do have a use case that requires setting up and tearing down of your clusters, then automation is critical. If you're doing that in a multi-cloud environment, then your automation needs to be tuned to the cluster lifecycle APIs that are specific to each of these cloud vendors. Each vendor has their own different ways of handling authentication, authorization, policies around who can and cannot access your clusters, access control policies, etc. And trying to kind of tie that all together or keep that in mind as you build that automation can add to some of the complexities. If you are managing large scale clusters, like if your use case requires creating multiple clusters, each of which is, larger in size. When I say large scale clusters, I'm talking about clusters where the nodes start approaching close to 100 or start going beyond that. At that point, you really do start running into some of the core Kubernetes complexities themselves, etcd, backups, etc., or some parts of control plane, failures or other scenarios when you're doing rolling upgrades of the clusters become more common in our experience in Kubernetes when you start deploying clusters at scale. And so managing that with one or two clusters deployed on a specific environment is a challenge enough. But now if you're doing that across multiple environments, it just requires much closer attention and skill set.
What I'm hearing here is as you're describing all these different things, if you're not going to run one single cluster in one single place, you must utilize the software-defined features of Kubernetes, the characteristics of Kubernetes. And everything, you don't need to be clicking around. Everything needs to be software-defined and automated because you're going to have this repeatable again and again.
That is absolutely right. Yeah, in fact, some of our largest scale customers that have deployed Kubernetes clusters, for example, on, let's say, hundreds of sites, right, have every single step of those deployments automated and have the ability where they can completely tear down the entire environment at a specific site on a moment's notice through automation and bring it up again based on a desired state config, completely brand new, and their apps will not get disrupted or at times will have minimal disruption. So that's probably an extreme of an automation, but it's definitely required once you go in the hundreds of sites scenario. But even if you're less than that, automation, we believe, is a key.
Cool.
So those are typically the kind of challenges that we see management. And then the last one, which is not mentioned here, but is equally important, is your application layer. And if you're building your applications, there's a number of considerations when you have a multi-cloud strategy. Are you going to want to deploy a scaled out instance of an application with parts of it deployed on one cloud and parts on the other? That is a theoretical possibility, right? Other relevant questions are, if you're deploying multiple instances, independent instances on different clouds, then what's your failover configuration, if if one of the Kubernetes clusters is experiencing downtime, etc., are you able to transfer over either your workloads or your requests seamlessly to other Kubernetes clusters, potentially deployed on other clouds? I gotta say, in terms of the scaling out of a single application instance across different clouds, that case we see rarely done. It is definitely more complex to do, and in our own experience, it's much easier if you leverage multi-cloud but deploy siloed applications, which for their most part of their lifetime will run and live on a single cloud. However, you can easily shut it down and deploy it on any other cloud deployment if you have to, without things significantly changing. So we recommend that you build to that practice, just because it's much easier to do it that way. And we don't believe there are a lot of benefits in trying to scale your app out so that it has some instances deployed on one cluster and some on the other. You can certainly do that. Yeah, but I think the general complexity that arises just on this topic, and I'm gonna cover my point before we address some of the questions, and there's a raised hand here too. But the things to keep in mind is if you have a specific application, then if you have a specific, let's say a CNCF certified application, an infrastructure application like ingress controller or etc., which is needed, or some kind of load balancing that's needed for your Kubernetes application. Now, service load balancing is done differently for on-prem environments than it is on a public cloud, right? Public clouds like Amazon come built in with ELBs as load balancers that you can leverage, or a number of other load balancer flavors that you can leverage for your application. But if you're running a cluster on on-prem infrastructure, then service load balancing doesn't come as easy. You might have something like F5 or other kind of production load balancers deployed, or you might use something like MetalLB, which is an open source load balancer. It is something that Platform 9, for example, packages and ships. But those are the considerations the moment you start going in infrastructure specific Kubernetes apps that are components that are needed for your specific applications to run. Those are the considerations you also have to keep in mind.
And it's interesting because from a developer point of view, you would think that you're going to a container, right? So a container is a container, and you can go across. What if you're doing multiple clouds? The container goes across, but the piece that you might not be thinking about is, where is that image repository? Because on one hand, if you're going to be across multiple clouds, you could have an image repository in each cloud, right? And that gives you a little bit of high availability. And as your app scales out, it's scaling out from that quote local kind of repository. Or you have a global repository, and then everything is signed, sealed, and delivered in that one repository. But then you have networking challenges about each of these clouds need to get back to this thing. And you've created a single point of failure for applications if they're all going back to one. So very complex, right? And there's no one right answer there. Also, the Madhura just kind of jogged my memory a little bit about your K8s manifest that you might attach to your application for it to be deployed to Kubernetes. In there, you're going to be defining your ingress and your service accounts. Well, your service accounts and things like that are going to be ubiquitous across whatever Kubernetes you're using. But your ingress might change. It might be different per cloud that you're doing. So where does that go? Where does that live? And how does that get distributed and all that? So complexity gets ratcheted up pretty quickly when you get to multi-cloud environment.
Yes.
So we have a question here.
Yep. So one question on chat: how do you upgrade given the complexity of variants of Kubernetes versions across the platform vendors, etc.? Is there a base version across cloud platforms, or is that overhead addressed in Platform 9? So typically, when let's say you're leveraging Kubernetes across, say, EKS, GKE, and some on-prem using either DIY or on-prem vendor, typically, all of the vendors will try to follow a certain train model that aligns with upstream Kubernetes version release cadence, right? So upstream Kubernetes will release new versions once every quarter or so, and they're actually gonna planning on relaxing that even further. So let's say 1.20 is out, 1.19 and 18 were just behind it. You will see public cloud vendors like GKE, etc., upgrade the control planes of their clusters to 1.20 and then say, we also support, we have backward compatibility to 1.19 and 18, but that's it, right? So each vendor tends to have their specific policy or when it comes to how they'll handle the upgrades, what flexibility, if any, that they'll give you in terms of continuing to stay on older versions versus always upgrading the control plane to the highest version that they support and not giving you the choice of staying at older versions. And so that is something that you do need to keep in mind and understand in terms of what the different vendors' policy is. If you use something like Platform 9, then one of the things that we do is for your clusters that we deploy on-prem or public cloud, we do give you ability to standardize on a single version because you're able to create clusters with a specific version, and you're able to stay on that version for a longer period of time, right? The platform or the product supports multi-version capability, which means you have the choice of upgrading your clusters to different versions or staying at slightly older versions. And so typically what our customers do is they'll standardize on a version. Let's say in this scenario, they were on 1.8 and 1.9 and 1.18 and 1.19 and 1.20 come out. They'll then upgrade their staging clusters to 1.19. They'll test them. In the meantime, all production is running on 1.18. There are times when they may choose to not upgrade that quickly, and we give you that flexibility. So coupling that multi-version capability, the flexibility around how long you can stay on older versions, and the multi-tenancy feature of the product, which allows you to carve out staging environments separate from production and then test things out in staging, we believe really helps you manage this complexity better. And then lastly, all upgrades are handled the same way, and they're completely automated and managed by Platform 9. And coupled with a proactive support, if you're a paid customer of a growth tier or enterprise tier, where if we notice an issue with your upgrade, then we will proactively reach out to you rather than you identifying that problem and trying to open a support ticket with us, because we are a SaaS managed platform. So we have visibility into a lot of problems and errors that you might run into. And so you will see us opening a support ticket, reaching out to you saying, hey, we've noticed this problem. We're already on top of it. We'll get in touch with you if we need help from your side. So those are just few ways in which we try to help you address that complexity. Let's see. Are there any other questions, comments?
Nope, we're looking good.
All right, fantastic. So then with that, let's go next. So how does Platform 9 handle multi-cloud? So, in terms of Platform 9's approach towards multi-cloud, we have sort of a multi-pronged approach. We believe, there are different ways of helping you simplify your journey when you're choosing one or more on-prem or cloud destinations to create your Kubernetes deployments on. First of all, we start with what we believe is a fully in-depth and production-ready support for on-prem Kubernetes cluster environments. And there, we don't just stop at helping you create highly available multi-master clusters, but we try to go all the way up to helping solve some of those app-level challenges that David and I were talking about. So, for example, we provide a built-in MetaLB load balancer, service load balancer out of box, and we fully automate deployment, lifecycle management of that component. So then you can just consume it and use that for load balancing for your applications and services. Um, so on-prem, we have fully stacked up set of features, including all the way from bare metal automation to deploying Kubernetes clusters on virtual machines, VMware virtual machines, or just physical Linux servers, to also potentially running VMs using KubeVirt side by side with containers if you have those use cases. So that's for on-prem. Now, when it comes to public cloud, Platform 9 takes a two-pronged approach. We do create for AWS and Azure. We integrate actually with their IaaS API, the EC2 API, and the Azure's IaaS API to create Kubernetes clusters on top of the public clouds, leveraging all of the cloud native features. Like when we create cluster on Amazon, we are leveraging Route 53 for cluster Kubernetes API DNS configuration, and we're using ELB for load balancing across masters, and we are integrating with your VPCs, and we have support for integrating with different flavors of VPCs, whether you have a VPN set up across your on-prem site in your public cloud, we can integrate with that, and etc. So we kind of integrate with what you have, but we create the Kubernetes clusters on top of the public cloud's IaaS API. And we do that for a couple of reasons, right? When you are choosing to use EKS, for example, let's just take Amazon as an example, there are a number of benefits that come with it. For example, the control plane is fully managed by Amazon, etc. However, in our experience, if we are helping you with managing your EKS environments, etc., then the amount of control that we can exert there to deliver to you that fully white glove, complete hands-off service that we strive to deliver to you is limited at times, right? Because a number of cluster-related operations are already automated by the public cloud, and without much flexibility to influence them or tweak them externally. And so when we create a cluster for you on top of Amazon, we believe that in certain cases that gives you, essentially all the features of public cloud that you choose that cloud for, but with the exact same SLA guarantee that we provide contractually to you, which is our 99.9% SLA for your Kubernetes control plane and data plane and upgrades and etc. So that's the reason why we try to create clusters from scratch as an option, at least for AWS and Azure. But we don't just stop there. Recently, over the past 3 or 4 months or so, actually more than that, over the 6 months, we've started releasing ability for you to import your existing public cloud clusters. So starting with importing EKS clusters, which was released about 3 months or so ago, and just recently hot off the press in our most recent 5.3 release, which will go out to all freemium tier deployments in about a week or so. We've expanded that and added ability to import your GKE and AKS clusters. And the reason we added support for that is, again, to give you the choice, whether you choose to leverage our Kubernetes offering on top of public cloud, or you have specific reasons / existing investments in the public clouds already that you don't want to tear down. We still want to integrate with those environments and help you take them in and manage them. And we believe we can add a lot of value on top still. For example, one of the most recent features that's coming out in the product is profile-based management, and RBAC is the first component that we are looking to automate, or we are automating through a profile-based management approach. And what that means is that you express a desired configuration or a multiple desired configurations as profiles for RBAC configuration for different users across multiple clusters. And then you can just one-click apply those to different clusters. And that really helps. RBAC tends to be one of those pieces that adds to the complexity of managing multiple clusters, right? And so this kind of automation really helps you standardize on who gets access to what. And then our product will help you visualize drift with respect to that configuration and etc. So it's just a beginning of a series of such features that you will see coming out. And we'll do a dedicated session on profile-based management. So I'm not going to be able to demo that in this session, but just as one example of something that we're doing to we believe help you in managing the multi-cloud complexity. And then finally, deployment of applications across multiple clouds, clusters on multiple clouds. One of the things that we also recently, very recently, came out with is a certified app repository. That certified repository today contains Ingress Controller, but pretty soon it's going to have all of the other popularly used applications like Cert Manager and some kind of persistent storage and etc. And as we release these certified applications in our repository, we release them only after testing and validating those on not just our on-prem Kubernetes offerings or the public cloud Kubernetes clusters that we help create, but also on EKS, AKS, and GKE. And if those apps require specific separate configuration, like Ingress requires separate config to say to get deployed on public cloud versus private, we will release different versions of those Helm charts in our repository. So our goal is to kind of help you, essentially batteries included but optional, as we call it. So our goal is to get you set up with these combination of the multi-cloud capabilities and the certified apps, etc., so that you can, even in that multi-cloud environment, you are able to have some level of standardization and certification of apps that we have tested, and if you experience any issues with them, that we will go ahead and fix them. Anything more, David, you want to add before we switch into a demo?
Nope, can't wait.
Okay, fantastic. All right, so with that, folks, if there are no more questions, then let's switch to a demo. Okay, and so a couple of things to call out again here. As I mentioned, we recently added multi-cloud capabilities where you can import not just EKS, but AKS and GK clusters. I will not fully be able to demo that. It's just completely hot off the press right now. But we will do a follow-up session, which kind of demonstrates that, in one of our upcoming AMA sessions, as well as the RBAC profile capability that I just mentioned. It's also going to be something we'll be demoing in a dedicated session. So know that it's coming, but today we will keep this focused on the specifically just the multi-cloud built-in features in the platform that we have today. Okay, so this is for those who are completely new to Platform 9. This is Platform 9 user interface. If you create a freemium tier account, you will in seconds be able to see something like this, although your environment will be empty, versus in my environment, I have a few clusters and nodes and pods and etc. Each deployment of Platform 9 is backed by a dedicated separate instance of our management plane. And then you are able to bring in your own infrastructure, whether on-prem, your own virtual machines, physical servers, or you can integrate with your public cloud accounts. Okay, so to help with that, management of multi-cloud environments and the complexity, one of the key features we have in our product is multi-tenancy, right? It's just a built-in feature into the product. At the top right here, as soon as you sign into your product in your PMK deployment and you see the dashboard, you will see two things. There's a region dropdown and there is a tenant dropdown. For freemium tier customers, the region dropdown never really changes, and you don't have the option of creating multiple regions. But for our paid customers, our growth and enterprise tier customers do have the option of creating multiple regions. And what happens behind the scenes is we create dedicated deployments of Platform 9's management plane, that is hosted by us for each region. And so this becomes valuable as as enterprises have security and isolation regions. They want to deploy a region in a specific geographical location. I'm realizing I'm just having a difficulty with the words region and reason. So yeah, that's one reason why our customers ask us to deploy multiple regions and potentially deploy them in different geographies. Other reason is just scale. If you're deploying really large scale environments, distributed geographically, then regions are just another way of helping you manage that scale. The other feature is tenancy. In this, everyone in free tier and all of the other tiers have full access to. The way to access this feature is go to your this user profile drop down and then go to admin settings. And then you'll see the tenancy features here. You have different users that you can add to the platform, multiple tenants that you create. Each tenant has its own dedicated set of clusters that will not be visible to other tenants. Users can belong to one or more tenants, and there are two roles that are supported out of box. Administrator has access to everything, and then self-service users are only assigned to specific tenants by admins, and then they are given specific RBAC roles before they can access clusters within that tenant. So this really helps you make good sense of your multi-cluster environments while keeping different environments segregated, production separate from staging. Only some users have access to production, lots of users have access to staging and dev testing, etc. Okay, so moving on to infrastructure, you see a few tabs here. The clusters tab shows you all of the clusters that you have created using Platform 9 managed Kubernetes. So this would include clusters that you've created on premise, using your physical servers or VMs or etc. It'll also include clusters that you created using managed Kubernetes and our IaaS level integration with public clouds. So for Azure and AWS, we let you create Kubernetes clusters where we leverage their IaaS layer to create those clusters, and those clusters will show up here. The imported clusters tab shows you only the clusters that we've helped import from EKS, AKS, or GKE. So here I actually have two clusters running. I have one that was imported from an EKS or an AWS account. It's an EKS cluster, and another that's a cluster running on Azure AKS. And so you can see this cluster is running on 118.14. The EKS cluster is running on 119. And there's a number of other parameters here. So just at a high level, being able to import and manage clusters here gives you that single pane visibility where you can look at various clusters, their running state, if they're having any issues, and what versions of Kubernetes they're running on, and etc. Switching to the nodes tab, this only shows you nodes for the Kubernetes clusters that are created by Platform 9. So if you have EKS or EKS imported clusters, those nodes will not show up here. You'll have to see those nodes by logging into the specific cloud portal. But especially for your on-prem clusters or public cloud clusters, you're able to really dig into specific nodes and their health status. If certain parts of the control plane are having issues, you will see that raised over here. You can dig into a specific node and see health of that node. Look at all the detailed parameters for that node, look at different versions of different components installed, and etc. Okay, you also have really quick ability to view logs of these nodes. This is something that I just like to call out because sometimes this cannot be obvious, but it really helps in debugging in certain scenarios when your clusters are having issues. Okay, so what are some of the key steps to building your multi-cloud environment on managed Kubernetes? If you are building your multi-cloud environment using at least one public cloud, then the first step you need to do is you create what we call a cloud provider, and you supply your cloud credentials there. So you would create a cloud provider for AWS, Azure, or Google Cloud. In case of AWS, for example, there's a certain set of configurations, IAM configurations you need to do to make sure that this account that you are creating has the right kind of privileges so that we can create all the underlying AWS resources that we need to create behind the scenes, especially if you're using this account to have us create a Kubernetes cluster on top of AWS. So that's the first step. You create a cloud provider for your specific public cloud account. We have documentation that gives you detailed requirements for everything you need to do to successfully create a cloud provider. Once you do that, then you would come to cluster creation. And at this point, you have the choice of either creating a cluster or importing a cluster. Let's look at importing the cluster real quick. Let's say you want to import an AKS cluster. At this point, the wizard will ask for an existing cloud provider that you had pre-created in the step that I just showed so that you can import a cluster. So I have this Azure cloud provider hooked up right here nicely. So I'm going to just select that. And so now the wizard is showing me the various regions that actually have AKS clusters. So it kind of does this nice filtering here where it only shows me the regions that have any AKS cluster deployment. And so I'm going to just select one of these regions here. Let's see, West. So there's a cluster here, and I'm going to select that cluster, and I'm going to go next, and I'm going to say import. And that's it. That's easy as that. The cluster should get imported. If there are any issues because we didn't have the right privileges with the cloud provider, that will typically be the reason you will get an error. But importing clusters otherwise is that easy. Similarly, you can import EKS and GK clusters. But once you have those clusters available, now when it comes to deploying your workloads or all of the other features, developer or app level features that we spoke about, you're now able to essentially use them in a consistent manner, right? For example, the application catalog, that's something we just spoke about. I've configured this deployment with our Platform 9 default repo. It's this repo here. And then in the app catalog, you can see that the Nginx controller, for example, there's 2 versions of Nginx that we provide as part of the repo. Deploy Nginx using, deploy ingress using Nginx as a reverse proxy, or deploy ingress when there is an external load balancer that might be already present in your environment. So that kind of goes back to that standardization I was talking about, where we put in effort to test these apps, and there's going to be a lot more coming in this certified repository. We put in the effort to test them across these different cloud vendors, and if we need to create different versions of them to support those cloud vendors, then we will go ahead and do that. So that's one kind of key benefit when you're managing especially imported clusters and trying to standardize on a single process or single way of deploying and managing applications on them. Arbeck is another. Yes, go ahead.
Sorry, I'll just give you a quick time check here. We're about 10 minutes away.
Okay. Yeah, I'm almost done here. Maybe just a minute, and then we can open up to questions. But that's essentially a summary of the capabilities, right? But the thing I was going to talk about is Arbeck. And again, that's one of the key pain points we've seen with a number of customers, and just being able to standardize on that has been a key feature we've heard. And so that's coming up, and we'll showcase that in one of the next sessions. But let's pause here. David, anything you want to add, or should we open up for questions?
As I was introduced to the app catalog feature, from my point of view, normally I would take an application, containerize it, put a manifest on it, and deploy it. And that's kind of classic Kubernetes, deploying an application. An alternative to that is using Helm and taking your application and wrapping it up in a chart. And the funny thing is, like, I've always felt like that was for vendors. But recently I did a piece about deploying a Spring microservice application using our app catalog. And I wrapped the application up in a Helm chart. And what I realized was this is actually pretty powerful, because the distribution of the application across multiple clusters, if I as a developer just wrap up my application as a Helm chart and then internally make that my distributable, not the container and the manifest separately, but make the Helm chart the distributable, then it could be added in here and it could be deployed to any cluster, right? I don't really care what cloud I'm on or anything like that. That was a pretty cool notion to me. It introduced some pretty nice distribution channels, if you will, for doing things in a multi-cloud way, but not feeling like it's multi-cloud, just getting the job done.
That's right. Yeah, absolutely. Okay, so let's open it up. Are there any questions, comments?
Quiet crowd.
While we wait for that, one thing I want to highlight is the monitoring feature. Again, monitoring of clusters becomes one of those top things that adds to your complexity, especially if you have different ways of monitoring different clusters. And so one of the things that we provide is we do give you the ability to deploy Prometheus on across various of these clusters, irrespective of where you have them deployed. And then we have these nice built-in dashboards that actually highlight to you some of the critical things, like critical events and alarms, etc., that might need your attention. David, you were saying something?
No, I'm just watching here, and we've got a quiet crowd today, listening intently, I'm sure, to your every word.
Yep. So folks, any comments, etc., feel free to share on the chat or ask on the questions. Otherwise, I'll keep going and showcasing a couple of more features here that might help you in your multi-cloud journey. Okay, so a few more things here. As we were talking about multi-cloud, we discussed that one of the key challenges with multi-cloud is managing upgrades. And so, okay, let's see. I think we have one question here. Yep. Can you register custom apps, Helm charts, and that would be available, reusable to deploy across multiple clusters? Yes, you can. So the way to do that is to go to the apps section here and plug in your own repository. You can always also start with some of the public repos, like the Bitnami repo, for example. It comes with a number of charts, not certified. So, you got to kind of deploy them at your own risk. But more importantly, and this is what we do ourselves internally, and we, our customers do too, which is they build their own repo once they get to that stage where they will have their own custom apps that they've tested across different clusters, and then they'll just hook it up here. And then once you have it, now it's available, it's configured. We configure it for all of your clusters, or you have a choice of configuring for a subset of clusters. So then you can just use that way, to David's point, to standardize deployment of those apps across different clusters.
Let me extend that a little bit, having just gone through this exercise.
Yep.
So let's actually take the more difficult one, and that is private. Right, we're going to do custom applications, which probably means they're very internal, right? Nothing public repositories would hold or anything. Internally, let's say you're using GitLab to hold all your source code. Developers are using it to develop. What you can do is inside GitLab, you would create another repository that is a Helm repository, or sorry, just another repository in GitLab. Within there, you're going to configure it as a Helm repository. And so that's a typical thing. You can go on Helm and learn about creating repositories and all that. It's just a couple of YAML files that you add in there. Mm-hmm. That then inside that Helm repository, inside your YAMLs, you register your application right there, and you actually are going to post a compressed artifact of your application. Wrap up your jars, wrap up your DLLs, whatever, in a zip. So here, what Madhura just showed you about adding a new repository, you would grab the URL of that Helm repository that you created in GitLab and put it in here. So the connection point here is your clusters are going to have access to that GitLab. And that's probably a bit of an inflection point there, right? Because that's where you're marrying up your ops and your dev, more or less. All right. So I hope, Austin, that kind of helps you in thinking about this and reasonable ways to do it across multi-cloud and all that. We got another question. How does containers reduce costs? Can you give some examples? VM license, OS infrastructure, cost. So I guess I'll start on this one, Nick. I'm going to assume when you say containers, you're thinking about custom applications running in those containers. So as far as reducing costs go, it's a bit of an abstract thing, I guess. On one side, you may have those applications running on dedicated infrastructure. So it's running in a very defined, finite compute environment. And those machines are probably, that infrastructure for that application has been sized according to how much it's going to have to burst, right? How much use it's going to be. And typically that dedicated infrastructure is only used, a small percentage of it on average throughout a year or something like that. Once you change over to containers, now you just need to have a hyper-converged layer there. So that means all of your infrastructure is just, is utilized ideally 100%. And then you run however many containers of your application on that hyper-converged, right? You also might use a platform like Kubernetes or something like that to manage those containers and the scheduling and everything of those containers. From a licensing infrastructure cost kind of perspective, your infrastructure is very basic, right? Very basic hosts, very basic things. So hopefully your licensing costs are pretty low. Then your containers, to run your containers, I wouldn't say there's much cost there, right? You can run Windows containers. Windows, of course, is the most expensive. But your base OS for a Windows container doesn't cost anything, right? Or your base OS for a Linux container doesn't cost anything for it. So you can run as many containers as you want. I hope I'm helping there, Nick, answering your question. Please let me know.
Let me add just a little bit to that. I think like one obvious way in which containers help with cost is you can stuff in more because they don't carry the operating system image like VMs do, right? Like David said, so you can pack in more. But to be honest, Nick, in production environments, the way to look at the savings that come from containers are not necessarily directly because of the packing benefit they provide, but more of the indirect cost benefit, because containers just enable you a much better high availability and application upgrade and update, etc. strategy, which historically has been difficult to do with virtual machines because apps that get built with VMs tend to be monolithic, tend to be scaled up rather than scaled out. And we had this problem ourselves too in Platform 9's history. Our upgrades of management plane would take significant amount of time in the past. And once we moved to a container-based deployment, that we were able to reduce that time of our, how long it took to upgrade our production apps. So those are just some indirect benefits to keep in mind. We also have some questions on the Q&A panel. So let's address them. First one is adding custom internal Artifactory as an app catalog. Is that available? Yes, it is available. You can, I believe, David, if you have more questions, actually, Matt is going to answer this question.
Yeah, he's covered a couple.
He's already covered it. Okay, great. How Platform 9 differentiates itself from other Kubernetes management platforms like Rancher that have been in the market and have a richer repository. So this is a great question. The biggest way in which, Arindam, we differentiate versus Rancher, and we have customers, a number of them that moved from Rancher to Platform 9, is in our SaaS-backed production grade support and SLA that we're able to contractually provide to you. And that especially becomes relevant as your environments become large and complex. We guarantee a 99.9% SLA to you, and you can get credit if we fail to deliver that to you. And we're one of the few vendors who's able to deliver that because we have full visibility into any problems or issues that are going on in your deployment through our SaaS hosted management plane. Versus with someone like Rancher, your operational model is more typical traditional model where you experience an issue, let's say with the management plane or cluster upgrades, you have to open a support ticket and then you have to, hope for that to be resolved that way. I would say a big percentage of issues of our customers get proactively monitored and detected and resolved by Platform 9. So that's just one way in which we differentiate in a big way compared to a vendor like that.
And we're at time, but I'd like to, if you don't mind, I'd like to extend this because we've got some pretty good questions in the Q&A.
Yep. Let's go ahead and do that. Next question, how easy is it to do fleet management considering the clusters vary across different providers, like doing bulk upgrades for Helm charts, apps, or etc.? So when it comes to bulk upgrades for Helm charts, etc., we aren't at this point, I'm going to be honest, providing any capabilities out of box for this. It is something we're working on when it comes to the profile-based management that I was just talking about, and it's something we're just super excited about. We think this feature is going to help in various different ways, but we're going to expand that beyond just our back profiles, and we're going to give you ability to first at infrastructure layer automate the deployment and upgrades of your clusters by specifying desired state configs. And then, we kind of just behind the scenes make sure that happens. And then also at the app layer to be able to do bulk upgrades, etc. The app bulk upgrade stuff is a bit tricky, to be honest, though, because you kind of want to orchestrate upgrade of your applications. So you want to retain more control. For example, if you have production apps deployed across multiple clusters on different environments, different clouds, typically the way we recommend doing it is obviously using automation. You can use Helm and Helm's own set of built-in capabilities for that automation, but you kind of want to orchestrate that in stages. And so there's a number of nuances that are involved there, which is probably a separate topic in itself. And maybe we should cover that in a different AMA session. Let's see. Can you please talk to the pricing model? Is pricing per cluster node parts? Do you bill by the hour only when the cluster is up? So pricing is per node pricing. It's a fairly simple pricing model. In fact, if you go to our website, you'll see pricing for growth tier on the website. And that's the next immediate tier after the freemium tier, which is completely free. And so it's per node for on-prem nodes. In public cloud, it's per vCPU based pricing. Okay.
Awesome.
I think those are the questions we had. Any other questions or comments, folks? Also feel free to reach out to us on our Slack channel, and we will, we'll be happy to help you there. But outside of that, folks, thanks for taking the time today. Thanks for attending the session. It will be recorded and posted on our YouTube and our resources page, and an email also should be sent out to you. With that,
cool. Thank you for hosting. This was great.
Fantastic. And thanks, David.
All right.
Have a good
See you,
day.
everybody. Thank you.